Most of the people who want to be here are here. Today's talk, it wasn't a deliberate thing for me to fit in with the 80s theme, but fortunately it does. Usual standard disclaimer we get at the start of any of these things, this is for test purposes and so you can secure systems. If you feel tempted to commit world domination or minor theft, please don't. Basically what we're going to be doing, the first part is the intro that you're listening to now. I mean, you can all read faster than I can talk, but basically we're just going to go through a quick discussion of the IBM AS400, what it is and why it is the way it is, and then look at some standard methodology for testing them and some of the tools you'll need and how to lock them down and secure them. And quick introduction to me, I'm some guy who used to be a programmer, got more and more interested in securing the things he was programming, found out it was more fun breaking into things and moved into pen testing and eventually got more and more fixated with fixing the things I was breaking and started to go back where I started from, with all the whole secure design and secure coding. Right, what I'm going to be talking about today is the AS400, and I'll give a list of all its other names in a few minutes because it does have lots of other names, varying difficulties in Googling them. And as I said earlier, some discussion of how the system was designed and why it is the way it is before we look at how to test it and how to break it. And I will apologise in advance, there will be no RPG programming and no COBOL programming throughout the entire thing. So apologies for any disappointment for anyone there. Surprisingly for such an old system, there are a lot of these things still about doing a useful job. And although it might seem a bit intimidating just from its weirdness or obscurity, they can be tested surprisingly easily. And the testing can be fun just because of the way the systems are. They're generally running a lot of services. A lot of the times when you do test these things, you'll find old systems transferring huge amounts of money around, a lot of the time still in the default state, so they are open to attack or in need of fixing in some way. And as I say, that weird sort of text-only interface, different shortcut needs, weird menu options, it might seem a bit intimidating, but from the point of view of scanning and attacking them, a lot of it does have some things in common with other systems. And I'll just show they can be tested much more easily than you might suspect. The AS400, it's gone through multiple name changes over the years, but there were huge numbers of these sold and still in use. Allegedly, there's more than 100,000 companies still using them today. Although the page I googled that from didn't give any data to back it up, it just made that as a flat statement. Importantly, if you talk to the people maintaining these, you'll look like a fool if you call it a mainframe. They are officially classed as mini computers, which is a term from the older days when a mini computer meant it was the size of a fridge. Sometimes in the modern world they're called a mid-range server, but that equally confusing language sort of classes Windows and Linux as low range and mainframes as high range. And it was developed in the mid-1980s. It was incredibly modern then, but now just looks cool more for its retroness. And it was aimed at sort of medium-sized businesses where they had it as some single powerful system. If you ever are looking at any system that uses any of these names, they're all basically the same underneath. It started off as AS400, changed its name to I-Series, and then the more you try and find out stuff about the security on these systems, they've started to apply names that are more and more difficult to Google due to their meaninglessness. But the name changes don't really seem to have stopped people just generically referring to all of them as AS400 or I-Series. By 1997, when these things were still fairly new, there'd been about 500,000 models shipped. The majority that I've seen and tested have been in financial sector. You can use them for ERP, supply chain management. As I said, there's a large number of services on them. When it was first came out, having your FTP, web, email, and all your applications in the same place was a big selling point. I've never, ever seen anyone using the web server on them. I'm more used to encountering vast surprise when people find out they're running an internal web server. And it was, as I say, intended to provide companies with this back office system, single powerful thing with a unified set of core systems. And it was supposed to alleviate the pressures on admins, but because everyone just needed one username and one password to access the web server, the FTP server, telnets, and the email and everything else that's on there, which was okay at the time, but has hilarious consequences nowadays. It looks like this. As I said, it looked incredibly modern, I assume, when it came out. It looks slightly sort of retro cool now. But that does have a benefit that anyone who sees you doing it, it looks like Hollywood hacking and looks like you're doing cool things if anyone glances over your shoulder. As I said, there's around allegedly 100,000 companies still using this stuff. A lot of these systems haven't been replaced because they're so stable, just running mass batch processing on financial transactions. I know of a company that replaced its mainframe, which was part of an 18-month-long project that cost £28 million. So that's the sort of scale of costs to bear in mind when thinking, why is this still here? Why hasn't it been replaced? It can be a lot of money needing a lot of justification to replace something so stable that's not broken and not doing anything wrong. If you do come to use any of these, a lot of the terminology might seem a bit odd, and the same words that you'd use on a different system mean something completely different. Other terms are totally unfamiliar. So I'll just go through a few of those to alleviate confusion for the presentation and if you ever have to look at one. If you ever hear anyone say OS 400, that's the operating system that sort of runs on these things. But a lot of the time people just say AS 400 to universally refer to the operating system or the hardware. It has something called the integrated file system that allows it to transfer files between Windows and Linux. We'll go into the whole thing about loose permissions on this later, but it does let you freely transfer files with normal systems. In general, dealing with a lot of the programming on these and a lot of the concepts, the configuration, the word objects is used a lot. Object-oriented programming was a new thing when these were designed. And like any new programming innovation, it was going to improve things, make everything more robust, reduce mistakes in programming, make programming faster. A bit like other programming innovations you've heard of. And so it was viewed that object-oriented programming and objects should be referred to frequently, a bit like when people discuss AI nowadays as the latest new thing that will fix everything, even if it's not AI. And so all the data files, the queues, message queues, everything on there is referred to as an object. And a library is yet another object that refers to the other objects. Files do not mean what a normal people would expect files to mean. A physical file is actually a record rather than any sort of Unix concept of a file. And the records can have variable lengths. It's basically like a spreadsheet concept of a record. And they can be, the physical files would be as they are written on disk, and logical files would be a logical representation of them with different records. Collections, if you ever hear that used, it's a grouping of related SQL objects. But that's because there's an integrated database, DB2 that is actually installed at the operating system level. So you can go directly into the database, search for stuff like usernames, user passwords, or settings in applications, again with hilarious consequences that we'll look at later. But okay, the boring stuff out of the way. You're now close to being an expert on AS400 by hacker standards, so we can have a bit of a look at testing. Can be done like the same methodology you would expect to use testing any application or system infrastructure of standard process, scanning, enumeration, exploitation and access, and the post-exploitation. We'll go through what tools are used for those and how to do that. Tools, you can get away with surprisingly similar stuff that you would use in most of your regular testing. Nmap and Hack 400 are the two things that are most essential if you are testing. Nmap and Nessus, good for the checking what services are running, and you'll be amazed how many are if you ever test one of these. Wireshark is just good for looking at the traffic, and it's helpful during a test to reinforce to someone that the system they are managing is sending people's passwords through the network unencrypted and transferring huge bank amounts of money to different banks unencrypted. You can connect to the telnet through the telnet service on this just through a regular command line thing. But if you can get hold of a copy, IBM iAccess is like a really good tool because it lets you have the proper coloured command line, but also it lets you inspect in a GUI way the databases and the file system. Somebody has very nicely created a free Java version of that as well, which I will show you if that looks like that. So you can download the Java version from that address on the screen. I am going to put all the slides online later. So ideally, you can do it with Telnet, but if you can't get IBM iAccess, use that Java version of the IBM client. Hack 400 is probably the most essential tool for this. It allows you to enumerate usernames, escalate privileges. It really just automates a lot of the processes that I'm going to show you in a few minutes. It has the advantage, it's written in Java, so you can just run it on Linux, or Mac, or Windows, and it has the disadvantage that it's written in Java. And it does look like that and lets you connect to the system and freely interact with it and do bad things, or security testing, as we call it. So for the enumeration, you'd begin with just running Nmap and Nessus against the system. You're really doing this to find out what services are running, but it does give a very strong indication of how well the system's been hardened, partly from letting you see what's been switched off or left in its default state. And interestingly, because Telnet, FTP, POP, everything on there has also an encrypted service where it runs on a different port. If you do run Nessus, it tends to mistake this for not being AS400. You will get some real vulnerabilities and some things that are in no way vulnerabilities. But from the Nmap results, you will get a good starting basis that you can use for your attacks and user enumeration. And as I say, it gives a very good idea of how close it is to its default states. It's important to scan every port because there is generally such a huge number of services running on there. If you are doing those Nmap scans, obviously leave out the square brackets and the made-up address, or for illustrative purposes. The important thing, if you do run Nmap and Nessus, is to don't just run them and then go away and leave it and make a cup of coffee and read a blog post. You will need to keep an eye on things the first few minutes. I've seen multiple descriptions online that it can cause excessive resource consumption, slow down the machine and cause major issues on the machine. I've never ever seen that happen, but very important to to not be the one wanting to give an excuse on what's happened to someone later on. And just be ready to switch them off. Those scam results then will give us that nice basis to work through. That is, I appreciate you probably can't read all of that from the back, but that's what you might see on a default state system, which gives you a huge number of things to look at. There's generally two, sometimes three web servers. You will find an email server on there, FTP server, if it's left as in its default state, and telnet server. Half the reason, or one of the good reasons, these are one of the main reasons you'd want to go through the scanning process. User enumeration is incredibly easy on these systems with Telnet and FTP. And if it's left in its default states, brute forcing is easy too, but I'm sure I don't need to tell you to check whether there's a limit on passwords. If you run Nessus against these, you universally get some false positive about SMB. It always looks like an interesting Nessus result, but it isn't. It's a false positive. I'll give you some boring link to read at the end for that. A lot of the time I've found speaking to people about, or speaking to a certain type of person at some companies about unencrypted Telnet or FTP maybe doesn't quite sink in as much as using Wireshark as well to show them a large cache transaction going through the network or an admin passwords. In terms of the username enumeration, there's an incredibly useful list from IBM of default usernames. So we can sort of avoid any random guessing. It's just straight to the IBM website and check which of the default usernames still have their default passwords, which of them are enabled. And as I said earlier, each username that you manage to enumerate or account that you crack that's on Telnet or FTP will give you universal access to that user's Telnet, FTP, email, the default web applications, as well as any applications that user uses. And there are different ways of escalating privileges, partly because of that weird stuff I talked about earlier, where every user is an object and different objects have different permissions. But we'll look at the ways to do that later. There's a useful command you can use on the AS400 command line that will just list out all of the accounts, default accounts with a default password on there. For the purposes of a pen test, it's the real safe usage is the top one that just gives you a list of default accounts. If you want to play things a bit risky, you can disable all the default accounts that have a default password with the second one. And for anyone who really wants to live on the edge and take risks, you can disable all the default accounts with a default password with that final one. those are from IBM's webpage. Those are the list of user accounts I would expect you to see. And for each of those, if you do find those still enabled, always worth checking, because their default username is the same as, default password is the same as the username. And that is non-exhaustive. There's IBM give lists in different places of different user groups, partly because some of those I think are universal to IBM, and others are universal just for the AS400s. Part of the reason I said username enumeration is so easy is because of this lovely set of very specific error messages you get if you try and log in. It will generally tell you if the username's valid, tell you if the username's invalid. You can, if you're a masochist, type it in yourself, or write a Python script, or AS400 will do it for you. So if you were doing it by hand, you would basically do it that way. There's a different set of error messages for Telnet, FTP, POP3, but you can go in and just check whether a username is genuine, which usernames exist. And I would suggest always do this with Hack400. I'll give a list of links at the end, but that's a simple Python script that would go through and just check any bunch of usernames you give it against a system and tell you whether they're valid or not. I appreciate you probably can't read that from there, but I'll give you a link at the end for where to download all this stuff from, and I will be putting the slides online. The default login limits for each user is, there is no limit by default. I'll show you how to check that later, but you can use that, take advantage of that to try and brute force. If there is a limit, it's not unusual for admin accounts to have the same password across machines, or users to have a username equals password. It's not a quirk of the system, it's a quirk of the people who set them up when they were starting out years ago. But as I said earlier, one thing that can really help you reinforce the lack of sensibleness of using Telnet and FTP on these is to use Wireshark, depending on the scope of your assignments. I mean, you might want to try and get an admin password from floating through the ether. So, if you do use Wireshark to look at any of this traffic, just as you run Wireshark by default, it can be a bit deceptive. It will look encrypted and look weird the first time you see it. That is because AS400 does not use ASCII encoding. It's, again, so old that that wasn't the accepted standard at the time. So if you run Wireshark in its default state with ASCII encoding, you'll just get what looks like some unreadable mess. You might mistake it for being encrypted. But if you switch to EBCDIC coding, it all suddenly becomes readable. That's not any real company's passwords. It's a screenshot from somebody's CTF that I found on the web. So No parties have been endangered. As I said earlier, it's got this thing, like as you're working through your results and looking for ingress points, there's this thing called the integrated file system, which allows your user account to just browse through whatever files on there you've got permission to use, either in the command line or through the iAccess GUI. As I was saying about these design considerations, it's a machine from a time when Wireshark didn't exist, PCs didn't have a network card, and security for mainframes was a locked door. So the integrated file system actually made sense when it was introduced. And from that iAccess screen, you can go through and look at whatever files you've got permission for. And you can also browse it from the command line, where it looks a lot like Linux when you're browsing it from the command line. You just use this command QSH, which is short for Q shell. Those object permissions are, in the sense of the file system being a collection of objects, are what are applied by default at the root. And I know I'm going on a lot about the defaults on these being very permissive and very unsafe, but with that default setting as the root, it's inherited throughout, and every user would be able to see every other file and every other user's file. So if you were in a situation where you'd got access to that GUI, you could just go round casually looking for anything that you might find interesting through there. You might find a lot of the time that there's other dependent systems that just assume that you can see every file. So sometimes you do find situations where anyone attempting to lock down folders or files finds that they break some dependent system. But from the command line, if you type in that Q shell thing, you get some Unix-like list of files with various sort of permissions listed. That was the best picture I could find on the internet, but when I've done it in real life, you'd get a standard kind of Unix list, but with RWX, RWX, RWX for everything all the way down, which always becomes one more screenshot for the reports. Having showed you all that complex stuff on how to do it with great difficulty from the command line, I'm now going to show you an application that does it all for you. Almost so you didn't even need to know that stuff. But AS400 is the sort of Rolls-Royce of these test tools for the machine. It will carry out all the user enumeration I talked about. It will do that automatically and give you a list of users on the machine. You do need a single login to the machine to actually run it. But for those users as well, we'll do privilege escalation, and we'll bring back hashes, and you can use it if you know within some constraints for exploiting the applications on there, looking at the database. As I say, it's got that Java interface that I showed you earlier. It comes in 3 separate jar files called scanner, exploiter, and auditor, with fairly descriptive names that sort of make things obvious, but the scanner application will use your user account to go through that process I discussed earlier and list all the users on there. And it gives you this button you can just press to escalate privileges to a different user that's listed. I'll discuss later how that's done. It's not always possible. It depends on the settings on accounts. But really, it just does all that for you. And it can, as I said, the exploiter can grab the password hashes from each of those users if you've got a user with sufficient permissions. Again, those aren't anyone's hashes. It's a screenshot from the internet. So any hashes you get from there, you can crack them yourself. There's something called AD Self-Service Plus, which allows the AS400 to sort of synchronize with Active Directory. So if you've got hashes from there, you might be able to abuse those in further ways, depending on whether that's switched on or not for the system. And you can generally, yes, just go through, crack a load of hashes get the password for the privileged user. In the report, the cracked hashes can frequently just become some reporting item of users who have the same password as the username, users with short passwords. The auditor is useful for reporting purposes and useful for fixing it purposes, and the most boring of the 3 applications. If you've got a username with sufficient permissions, you might as well unclick that use SSL before you start, because I've never found one that's been set up encrypted in all my years of testing AS400s. But that will go through and check a huge number of those settings on what they refer to as objects, and check the default check the operating system setup. And it will tell you straight away if you can find things like unlimited login attempts, or if the password complexity setting isn't switched on. It'll generally tell you about all the unencrypted services running on there. It does give its output in the form of a very long spreadsheet, so it's not really an adrenaline-based exercise to work through it. But it does nicely put a red highlight on the worst things, amber for the not so bad, and then yellow and green. The exploitation is done with, coincidentally, the Hack400 exploiter. This again has one of those lovely Java screens that I showed you earlier. And it relies on a lot of the issues around user permissions on there. Frequently, the user permissions on there will relate to the applications running, where normal person working in, say, an investment bank will have permission to request a cash transaction. Their supervisor will have a permission to approve that transaction. And that sort of thing would be enforce the security of the transaction, because they'd be mutually exclusive. You can either have permissions to request it or permissions to approve it, but no one can approve their own request. One of the things Hack 400 is kind of doing behind the scenes when it escalates for you, and one of the things you can do for yourself in the command line, if you really like that kind of thing, is to look, there's this API here that will list all the users, or certain user authorities, to describe the sort of thing I've just discussed, where if a user has certain permissions, they can escalate to another user without providing any passwords, which then allows you to alter things in the database, to do things you shouldn't be able to do, or to just escalate privileges to that user. And you do this with this command here. If you do it in the AS400 terminal, you will get it on multiple screens and go through some painful process of trying to learn the shortcut keys and screenshotting every page. If you do it in Hack 400, you get this nice sort of formatted thing here. What this shows is for those users there where they have, I think, OPR and exist, whatever was on my previous slide, those users at the top, and then third and fourth row and the row near the bottom can escalate privileges to another user without a password. And once you've got that, you can obtain, and once you've got that ability to escalate, as I said, it makes a nice demonstration for anyone where you're proving the insecurity of the system, that you've used that to then get sufficient permissions to get other people's hashes and give them a patronising sort of report item on bad passwords after you've cracked the hashes. You can execute commands that you wouldn't normally have permission to access, and you might be able to improve your database access with that sort of increased privileges. And you might remember near the start I said the database is integrated at the level of the operating system, so that PrivEsc can enable you to start querying the database, altering stuff in there, like literally like user passwords, or that whole thing of setting permissions and conditions in a financial application. As the sort of thing I described earlier, if one user has permissions to request a money transfer and another user has permission to approve it, you can abuse a system in that way. You might need to speak to the client, get an understanding of their systems, and look at how you can sort of do that unauthorized transaction. The system I did that on, we were restricted by the size of the input field and could only steal 99,999,999 pounds and 99 pence. But obviously you could do it more than once if you need more than that. If you're interested, and hopefully you are after that, in using the database to do that kind of thing, you just do this STRSQL command and it happily signs you into the database, and you can start querying that for the fields you need and for what you want to change using something that looked modern in the 80s and looks retro cool now, but that can, depending on what your user's database permissions are as well, it can free you from a lot of access level controls, where if there's processes relying on multiple users to approve different things, you might just be able to go into the database and change those yourself. And you can also abuse the database to get access to other accounts. That first SQL statement would be the kind of thing you'd use and to just bring back all the fields that look like they might be holding a password. And provided you've got sufficient permissions to query that table, you can just bring back those list of tables and just get from the results in there. It's obviously easy to use select.star. Just bring back the usernames and passwords. Or to not even bother with that and just do as I said earlier and change large amounts of money directly in the database. And the iAccess GUI can also give you this reasonable degree of freedom in looking through all those system-level databases and poking around and looking what's in the different tables and different fields if you can put up with its slowness. Right. Obviously, we're not just talking about this for the purpose of breaking them, as much fun as that is. The reason we're allowed to break them is so we can lock everything down afterwards. So for the mitigations for some of these are quite simple. The whole sort of unencrypted user accounts, there are terminal encryption settings that you can use to lock those down and defend against those. The user accounts, it's certainly not unusual in some of the tests I've done to find an account that hasn't been accessed since the 90s or default accounts on their weak passwords. There are sort of settings you can put in place to just disable those unused users and to enforce strong passwords. Some of that privilege escalation stuff is a lot more difficult because it needs somebody to go in and alter their RPG program and make it, maybe look at the design issues around that. Some rewrites to protect things better. I've never ever seen anyone actually using the web server and the email server. There's a lot of things on there you can switch off, which can be done in a safe way or an unsafe way. And for a lot of those application controls I talked about, it really depends on database permissions, putting the database permissions at the same level as the application permissions. Right, the terminal encryption can be enabled. During your initial Nmap and Nessus scan, you'll see if the encrypted terminals are there or not, because instead of using 23 for telnet, it uses 992 for encrypted telnets. And that will defend against all that packet sniffing, those credentials going over the wire, and that sensitive data being exposed. There's an IBM reference page that I've got about 4 slides of links at the end on all this stuff, but there's an IBM reference page that lets you know the encrypted versions, port numbers, that it looks like that. So there's, for FTP, Telnet, email, web service, there's a different encrypted port for each regular port. One of the easiest things you can do for defending these machines that causes the least damage and the least inconvenience is that there's 2 settings where you can just enforce complexity and you can limit failed logins. The default is no password complexity enforced, and the default is no limit on failed logins. So with these settings, you can just switching on Q, that top one, will enforce mixed case and minimum length. And the Qmax sign, it defaults to no max, but you can set that to a sensible number like 5. And obviously deactivate default accounts where you are reasonably sure they're not being used. For a lot of the FTP email web servers, you can switch them off. It depends on the use of this command here at the bottom, which you should use. The default use of that command, if you just enter it and press enter, is to switch off all services, even Telnet, which would then require a physical reboot of the machine from someone in the same room. So go to the references at the end and use it with parameters to actually switch off the correct services. For the privilege escalation and application controls I talked about earlier, it's as much as anything down to application design. That's you can, if anyone's used that use attributes in a really unsafe way just because it was the easiest way to make their applications work, there might be instances where you can switch that off. And the authority should be set to, I guess all. I think you can do other things on that to enforce the use of a password rather than randomly letting people escalate the privileges with no passwords. But rough summary and conclusion from all of that, it's, as I said, it's a very stable, powerful system, and it's good at what it does, particularly for someone who wants lots of batch processing of financial records. A lot of the default states on it aren't really as safe as they were or as convenient as they were back then. It's more that it's lived into some future that wasn't foreseen. I'm not criticising the system. It is stable and it can be configured in a stable way. But if you are testing them, it can be a lot of fun because there's almost unlimited fun in account hijacking, privilege escalation, and finding nice ways to steal fictional money on a test system. If you do want to learn more, there's a few websites where you can go. And part of the difficulty in practicing with this, I think it's part of the reason they're still in this state of being unsafe, part of the difficulty in practicing an AS400 is because you have to pay a subscription for the operating system to IBM, so it's several £1,000s to get one and start actually using it. But there is that thing that I showed you earlier was me connecting to this public site. You can practice navigating around the operating system and using the commands on that. It is a public service. Somebody's just put that there to be nice. So it's, nice to not go and hack it and try and break it, but it is a nice place to go and learn. And it's facing you via a web server, so you won't be able to nmap it and find a lot of that fun that we did earlier. I'll put the slides online so that you can sort of get these references yourself. I'll tweet about that afterwards, but for anyone who has no desire to follow me on Twitter, I'll give you my GitHub name if you come up to me later. That top slide there is from the guy who wrote Hack 400. And so there's his slides there. And you can also watch his demo of it at Black Hat Europe. And as well as all those IBM security references, there's the Hack 400 tool can be downloaded there. That there is a proper explanation if anyone ever asks you why you're not reporting the SMB null session. You can just get your words from there on why it's a false positive in Nessus and not waste your time trying to test it. And for a lot of the underlying architecture and sort of design weirdness at the very sort of close to the metal end, that a lot of that is useful to know. I think we just have time. I've got time for questions. Yeah. Yep.
Are the AS400s actually being replaced, or will they just stay there for years and years to come?
I've never actually asked someone how old the actual box is. I assume they'd had it since the 90s or early 2000s because there was users who hadn't logged in since then. But I don't know if that's been upgraded or if that box has just functioned in its default state for 20 years.
I mean more of like migrating off to something.
Yes, I think it's certainly possible to do that from looking online.
What are the hashes for the password? What type of hash is it?
It seems to have an almost infinite number when I've done it of NTLM and MD5. There's some, usually you can get like nice, easy, crackable hashes. I don't know why there's more than one type, but there is when I've looked in it in Hack 400.
So is it similar to MD5 or something like that?
There is MD5 and NTLM. I assume the NTLM is for the supposed interaction with Windows.
Does it only speak IP? Does it only speak IP network protocol?
I don't know if it only speaks that. That's the only thing I've ever seen it using.
Do you ever get organisations say, we want you to do an unauthenticated pen test on this? Or do they always open up and say, look, let us know what's doing?
It's always been with credentials.
Yeah, okay.
It's normally they ask you they give you 2 or 3 credential types for like different users of a financial application, yes.
And are there any examples of these things been compromised and real money going?
Part of the reason I did this is like, I've never seen any evidence they've been compromised. A lot of the time they're internal only.
Segmented.
But yes, I don't know to what.
So you just cut the stuff out and then.
Yeah, I've never heard a report of one being hacked.
Not yet.
No.
Yeah.